And welcome back. As we go ahead and continue to look at recursion, let's go ahead and take a little deeper dive and take a little more behind the scenes look at how recursion works. So we of course talked about recursive methods. Recall, if you will, our method right vertical used recursion. And you'll notice that when we did this, we didn't do anything really new or different in evaluating the method call. We did right vertical 1, 2, 3. We treated it just as if it was any other method call that we've done in previous lessons. We simply substituted the argument 1, 2, 3 in for the parameter n and then executed the code in the body of that method definition. When we repeated the recursive call, right vertical 1, 2, 3 divided by 10, we simply repeat this process, of course, one more time. And then, of course, on and on until we got to the end. So how does recursion actually work and how does it end? Well, the Java programming language places no restrictions really on how recursive calls are used in method definitions. However, for a recursive method definition to really be useful, it must be designed so that any call of the method must ultimately terminate with some piece of code that does not depend on recursion. The method may call itself, and that recursive call may call the method again. And of course, that's what right vertical does. If you look in that one case, it is, of course, calling right vertical again. Now, this process may be repeated any number of times. We saw that, we could have it for 2, 3, 4, all the way up into the max integer size for it to be able to use that call. However, the process for recursion will not terminate unless eventually one of the recursive calls does not depend upon recursion to return a value. Just as we saw when we reached that last value. When we reached 1, it was able to say, oh, this is where you want me to kind of stop working through this and to kind of work backwards. The base case and the stopping case are two things that we're going to need. So the general outline of a successful recursive method definition is as follows. You have one or more cases in which the method accomplishes its task by using recursive call or calls to accomplish one or more smaller versions of the task, as we saw with right vertical. And you have one or more cases in which the method accomplishes its task without the use of any recursive calls. These cases without recursive calls are what we call our base cases or stopping cases, as they sometimes be referred to. And you'll see those two terms used interchangeably. Sometimes we'll call them base cases, sometimes we'll call them stopping cases, but they ultimately mean the same thing. So how does it tie back to what we're talking about with recursion? Well, if you recall, we have an if-else statement in our right vertical method, and it's often used to determine which one of those cases are we using. Are we using the recursive case, or are we using the base case? A typical scenario is for the original method call to execute a case that includes a recursive call. That recursive call may in turn execute a case that requires another recursive call. Then for some given number of times, each recursive call produces another recursive call, but eventually one of the stopping cases should apply. Now, every call of the method must eventually lead to a base case, or else the method call will never end. And you're going to get an infinite chain of recursive calls. Now, in practice, what this actually looks like is a call that has an infinite chain of recursive calls will eventually terminate abnormally rather than run forever. And we'll take a look at how that's actually going to work in your code. But first, let's talk about stopping the recursion. The most common way to ensure that a stopping case is eventually reached is to write a method that some positive numeric quantity is decreased on each recursive call to provide a stopping case for a small value. This is how we designed right vertical. So when the method right vertical is called, that call produces a recursive call with a smaller argument, because we went from 1, 2, 3 down to 1, 2, and finally down to 1. This continues with each recursive call producing another recursive call until the argument is less than 10. That's our goal, right? We're trying to find a value that can be printed out. When the argument, of course, is less than 10, the method call ends without producing any more recursive calls, and the process then works its way back to the original call, and the process ends. So that should give us some information to make a general form of a recursive method definition. So the general outline of a successive recursive method is as follows. You're going to have one or more cases that include one or more recursive calls to the method being defined, and these recursive calls ultimately should solve smaller versions of the task performed by the method being defined, as we saw with right vertical. Now, you're also going to have one or more cases that have no recursive calls. This is our base case, or base cases. We might have, of course, more than one. Now, there is a pitfall with recursion, and that is infinite recursion. This is something that you, as a programmer, have to be aware of. In the example of the method right vertical, the series of recursive calls eventually reaches a stopping point, right, where it no longer has any recursion being invoked. So that's our stopping case. On the other hand, every recursive call produces another recursive call, then a call to that method will, of course, in theory, be able to run forever. And when it runs forever, we call that infinite recursion. In practice, such a method will typically run until the computer runs out of resources, and then the program is going to terminate abnormally. So let's look at this with an example to really kind of put this in context. Examples of infinite recursion, of course, are pretty easy to generate, but let's look at one that, from a Java standpoint, syntactically is correct. However, it might generate some infinite recursion. So if you look at this, it's very similar to the right vertical method that we had, but we just have this new right vertical method, and it says new right vertical and divide by 10. This is not print line, and mod 10. So you notice this looks very similar, but what is missing? Well, there's no if-else statement, first of all. And so what is this going to do? Well, we are going to expect some infinite recursion. If you embed this definition of program that calls the method, the program is going to compile just fine with no error messages, and we technically run the program. Moreover, there is a certain amount of reasonableness to it. We look at the logic of what that program is doing, and it seems fine. We're dividing by 10, and we're printing out a value. It says that we're going to output the argument to new right vertical, first output all but the last digit, then output the last digit. However, as you probably have already guessed, when you call this version, the method is going to produce an infinite sequence of recursive calls. So for example, we call new right vertical 12, the execution will stop to execute the recursive call new right vertical 12 divided by 10, which is equivalent to new right vertical 1. The execution of that recursive call will in turn stop to execute the recursive call new right vertical 1 divided by 10, which is equivalent to new right vertical 0. This in turn, of course, stops to execute the recursive call new right vertical 0 divided by 10, which is equivalent to new right vertical 0. This, of course, has another recursive call to execute the same recursive method call new right vertical 0, and so on and so forth. You can see how we kind of have a problem here. We're not ever stopping. All right, because the definition of new right vertical has no stopping case. There's nothing to tell it to exit out of this recursive loop that we effectively have made. The process is going to go on forever or until our computer runs out of resources. And let's just go ahead and take a look at what that actually looks like in Eclipse. So here we have that new right vertical method plugged in. I have a simple statement here that's going to plug in, let's say 1, 2, 3. And if I go ahead and run this, you can see we get a bunch of red errors here right away, and it's a lot of them too. And if we look, it says right vertical 3, so that's just, of course, this print line statement. So that worked fine. But then when we call new right vertical, you can see we get this exception in thread main stack overflow error, all right? So what does that mean? Well, we'll talk more in this chapter about what stack overflow means, but you can see we get this error, and it just repeats over and over and over again. There's a ton of it in here, right? And so one of the things we have to kind of keep in mind is that with this method here, we have to have a base and stopping case. So if we were to instead use our other recursion here, let's say we looked at this one, here, if you remember, we have a stopping case. We have a thing that says, oh, when you reach this value, stop. In fact, if I were to take and copy this method over and add it in here and call that one instead, it's going to work just fine. The issue is here, there is no stopping case. So there's nothing to tell it when you reach a certain value, don't do that other thing anymore. All right, and that is very important when you're dealing with recursion, because if you have an infinite recursion like this, you're going to run into errors. Now, there are times when you want to have, for example, a lot of recursion, but infinite recursion is not generally going to be something you're going to aim for, because again, you're going to get this stack overflow error, and we'll talk more about what that means.